starting up with the second example here. Same idea, we want to remember those basic things. Velocity is the first derivative, speed, absolute value, velocity, acceleration, second derivative. But this time we have a rock thrown vertically upward from the surface of the moon at a velocity of 24 meters per second, reaches a height of s equals 24t minus 0.8 t squared meters in t seconds. So I'm on the moon and I throw a rock from the surface. So the rock is starting on the surface, throw it up, here is its position after t seconds. Find the rock's velocity and acceleration. Now velocity is the first derivative. There's my function right there. So the derivative of 24t would be 24. Then multiply by the exponent. 0.8 times 2, 1.6t. So there's my function that gives me the velocity. Acceleration is my second derivative. So I take the second derivative there. Derivative of 24 is 0. The derivative of negative 1.6t would be negative 1.6. And negative 1.6t. So my acceleration here is a constant, negative 1.6. Okay. When does the rock reach a velocity of 12 meters per second? When velocity equals 12. That's what it's saying. Well, there's a formula for velocity. So this would be that I need to solve 24 minus 1.6t equals 12. And so I just solved that. So negative 1.6t equals negative 12. T equals negative 12 divided by negative 1.6. And we ask the calculator what that is. 12 divided by 1.6. 7.5. Now, generally, I tell you not to give me decimals unless I give you decimals, but I gave you a decimal, 0.8. So you were given a decimal, so you can answer in decimals. So there's when the velocity is 12 meters per second at 7.5 seconds. And I think that looks pretty good. At what height? So now we want the height at 7.5 seconds. Well, that's just telling me to use my original function. S equals 24t minus 0.8t squared gives the height. So all I have to do here is S of 7.5. So 24 times 7.5 minus 0.8 times 7.5 squared. And then I just find out what that is. 24 times 7.5 minus 0.8 times 7.5 squared. 24 times 7.5 minus 0.8 times 7.5 squared. And that's 135 meters. It was measured in meters, not feet. Good scientists use the metric system. And so there, after I had the time, it was just a matter of plugging into the original function to get the height. Okay, continuing on with this example. Same function. How long is the rock aloft? So we threw it up, we threw it up and then it wants to know how long is that rock up. So we're not talking about any specific case right here. So it really isn't building on letter B here. It's just how long was this thing aloft? How long it was in the air? So the rock is going up and it's coming down. The time in how to explain this, I would ask a bunch of people in the classroom. We would figure it out together, but there's no one in the classroom. The classroom's empty. So the rock goes up and then it comes down. When it comes down, when it comes down and hits the ground, that's the kind of putting the end of how long it's aloft. We throw it up, it comes down. And so the length of time it's on the ground, we start again. It goes up, it comes down. When it comes down, that time that it hits the ground, there's how long it is aloft. And so it's aloft, and if you don't like the word aloft, we'll go with up in the air. It's up in the air until it hits the ground. That makes sense. Or when its height, and I do not need an apostrophe there on that one, when its height is 0. It's up in the air, it's aloft until it hits the ground, or when its height is 0. Well, height equals 0 would give me 24t minus 0.8 t squared equals 0. The height is given by the original function. And so I just solved this. Let's factor out a t. And so I get t equals 24 minus 0.8 t equals 0. It's now factored and equal to 0. And so I can split it up. And I'm running out of room here, so we'll just cut to the end here, and it shouldn't cause anybody tremendous difficulties solving that equation. We're going to get t equals negative 24 divided by negative 0.08, and 24 divided by 0.8 is 30. So it's aloft 30 seconds. There's my answer, 30 seconds. But here, this was just all original function. No calculus involved, because it really never talked about velocity or acceleration. Velocity and acceleration is my calculus, and it doesn't say anything about velocity or acceleration. It says, how long is this thing in the air? That's the original function. So we set the original function equal to 0. Now notice we got two answers. This first answer corresponds, t equals 0, corresponds to just before we threw it up in the air. It was on the ground at the beginning and at the end. What was the rock's velocity when it hit the ground? Well, that'd be the velocity at t equal 30. Well, previously, on the other page, we found that the velocity was the first derivative. Which was 24 minus 1.6t. So s prime of 30 be 24 minus 1.6 times 30. And that is negative 24, and that would be meters per second. Negative because it's coming down. That's a negative direction. Velocity gives us both how fast and direction. And the last thing, speed when it hits the ground. Speed at t equals 30 would be the velocity, absolute value of the velocity at t equal 30. That looks like 301 instead of the end of the absolute value. Or the absolute value of negative 24, or 24, and that'd be meters per second. And that's all we're doing in this section. So this is the end of this section and the end of this lecture.